Hello students, this is Mr. Ezra. Today we are going to be talking about how to find the roots of polynomial functions using synthetic division. So synthetic division is something we talked about way back in Unit 2, before fall break. And we've spent the first half of Unit 3, Unit 3A, the first half of Unit 3, talking mostly about the characteristics of polynomial functions and what the graphs kind of look like. So now we're actually going to talk about how to solve them, how to find the zeros with different methods and different techniques. First, we kind of want to review what is synthetic division. It's kind of our first goal today. What is synthetic division? We'll look at that first. Then we want to talk about how to use synthetic division to find all the solutions if we're given a root or two. If we know one of the zeros or one of the roots, or maybe more than one of the roots or zeros, can we use that information and synthetic division to find other roots or solutions? Do you remember how to use synthetic division? I'm sure after doing long division, we talked about synthetic division and you were like, I like this better than long division. Most students do, but let's review really quickly how to do synthetic division. Remember, when we're dividing synthetically, there's a few things that you have to remember. One is we do not divide by the factor. X plus 3 is called a factor. Instead, we divide by the solution to that factor equal to 0. So if we set x plus 3 equal to 0, we get x equals negative 3. That's the solution that we want to divide by, the solution to x plus 3 equal to 0, not this potential factor here. So we come over to the side and we put negative 3 at the beginning. Now we list the coefficients here in descending order, starting with the highest degree coefficient. But you have to do your countdown. Notice there's an x to the fourth, but we're missing an x to the third. There's no x to the third part. So we got 4, 3, 2, 1, 0. They're all there now. That 0 placeholder is important. So there's a coefficient of 1 in front of x to the fourth, and then 0, and then negative 10, negative 2, and 4. The signs are important, so be careful that you carry those down anytime you see a positive or negative sign. That part of the synthetic division needs to be positive or negative. Now, the steps were to, it's really adding down the 1, right? But we called it carrying down the first one. So we carry down this guy here and bring it down, and then we multiply. Negative 3 times 1 goes here. Then we add down. 0 plus negative 3 is negative 3. Then we multiply again. Negative 3 times negative 3 is positive 9. Then we add down. We multiply negative 3 times negative 1 to get positive 3. Add down to get 1. Multiply again to get negative 3. And 4 minus 3 is 1. This part here is called the remainder. So the last part is called the remainder. Remember, if you start with a fourth degree, then this is the coefficient of a third degree because we're dividing one of those x's out by dividing by x plus 3. So we get 1x to the third minus 3x squared minus 1x plus 1 plus, and the remainder goes over what we were dividing by, which is x plus 3. And that is how you divide with synthetic division. Hopefully it's come back to you and you're kind of remembering. If you want to pause the video and try this one here, and then start the video up again, and see if you've really got it, if you're really remembering how to do this. All right, so we don't divide by x plus 1. Instead, we divide by the solution to x plus 1 equals 0, which is negative 1. So we're going to divide by negative 1. We've got a fourth, a third, but we're missing x squared and we're missing x. So both of those need to go in before the constant term. So inside we're dividing by 2, negative 1. There's always an understood 1 if there's not a number in front of it. So 2, negative 1, 0, 0, and 4. Those placeholders are still important. Bring the first guy down, the first one down. So this is going to be bringing 2 down. multiply, add, multiply, add, multiply, add, multiply, and the remainder is 7. So if you've worked this out on your own, you should have ended up with 2x to the third minus 3x squared plus 3x minus 3 plus 7 over x plus 1. So since we started with an x to the fourth, this is going to be an x to the third. Our leading coefficient here was going to be, our leading term here is going to be a 2x to the third. All right, now that we've reviewed that, let's move on to the next step. Okay, I first have to talk about the difference between a factor and a root. Okay, factors are the things that multiply together to get the polynomial. If I'm talking about factors, I'm talking about things that look like this: x plus 2, 2x minus 3x minus 8. They're the things that are in parentheses after you factor. Roots are what you get when you set those factors equal to 0. So x plus 2 equal to 0 would give us a root of negative 2. 2x minus 3 set equal to 0 would give us a root of 3 over 2, and x minus 8 equal to 0 would give us a root of positive 8. These can also be called zeros or solutions. Those words are interchangeable, root, zero, solutions, and they also are x-intercepts, as we learned in our last, the first half of Unit 3, that these roots are also where the function crosses the x-axis. So we're going to use something called the factor theorem. Basically, if the remainder is equal to 0, when we plug in a number, when we plug in a root that we know is a good one, if the remainder is 0, then what's left behind is a factor, and this will probably make more sense once we look at a few examples. Before we get started, though, we could get a remainder using long division or synthetic division. But we prefer synthetic division. Usually it's going to be way easier. The last number using synthetic division is your remainder, and you've got to remember that that number is important. So that's why I draw that little L when we do our synthetic division to set my remainder apart. In order for this to work, that remainder has to be 0, or we are kind of stuck. A remainder of 0 means that what you're dividing by is a root, and you can use what's left over, as you'll see in a minute, to find other roots. So here is our first example. It says determine whether x plus 2 is a factor. Okay, think about this. If x plus 2 is a factor, if x plus 2 is a factor, that means that the solution to x plus 2 equals 0 is a root. If x plus 2 is a factor, then negative 2 is a root. So we're going to divide by negative 2, and we're going to know it's a root or not by checking the remainder. So really, this is just another synthetic division problem. Do my countdown, exponent of 3, 2, 1, 0. They're all there, so I can bring down my coefficients of 3, negative 1, positive 2, and negative 4. Remember, the remainder is what I'm looking at here. And I got positive 20. Since positive 20 is not 0, the remainder is not 0. That tells us that negative 2 is not a root, and therefore x plus 2 is not a factor. So the answer is no. X plus 2 is not a factor. The only way that x plus 2 would be a factor is if we ended up with a remainder of 0. We ended up with a remainder of 20. Well, let's check and see if x minus 6 is a factor of this polynomial function. In order to test that, we want to test whether the solution to x minus 6 equals 0 gives us a remainder of 0. So we're testing positive 6. That's what we're dividing by. That's the root, potential root that we're dividing by. Our coefficient, I'm sorry, our exponent countdown, 4, 3. We're missing the x squared, so we'll make sure we put that placeholder in of 0. X to the first, x to the 0. So we're going to divide into 1, negative 6, placeholder of 0, negative 4, positive 24. Remember, when you divide, that we're looking for a remainder of 0 here. And when I subtract 24 minus 24, I get a remainder of 0. Since the remainder is 0, that means that 6 is a root and x minus 6 is a factor. So yes, x minus 6 is, in fact, a factor. That's it. That's how you tell if something is a root or a factor, by synthetically dividing and checking to see if you get a remainder of 0. Can you use synthetic division to divide by something like 3x minus 2? Well, if you kind of go back in time, we know that we can use it for x minus 6. We know that we can use it for x plus 2 to see if it works. But can we divide by something like 3x minus 2? And the answer is yes. This is a linear function, so that we can divide up by it. You just set 3x minus 2 equal to 0 and solve, which gives you positive 2/3. When you synthetically divide, you would divide by 2/3. You would end up with some fractions as you go through your synthetic division, and that's okay. You just have to keep up with them and be careful. Let's put all this together, okay? If x minus 1 is a factor, find the other factors of this function. Okay, so we know that x minus 1 is a factor. We know that x minus 1 is a factor. So what we're going to do is we're going to set x minus 1 equal to 0. And we know one of the roots. Positive 1 is one of the roots. We will use that root to divide synthetically. I'll do my countdown, 3, 2, 1, 0, so I can just copy down the coefficients of 3, 8, negative 3, and negative 8. And my remainder is 0. Now, from this point on, I know that 1 is a root, and I know that x minus 1 is a factor because that proved it. What I'm going to do next is turn this into a quadratic. I've got 3x squared plus 11x plus 8. How did I know it was going to start with 3x squared? Remember, this was x to the third, so this is the coefficient in front of a degree 1 less. All right, so we're going to set this equal to 0 and find the other factors by factoring it. So we have to factor 3x squared plus 11x equals 8. Well, I know that 3x squared has to be 3x times x. So I need something that multiplies by to give me 8 that will work in here where the inside and outside products add to 11x. And I went ahead and did this. I got plus 8 here and plus 1 here. I'll show you the check. 3x times x is 3x squared. The outside and inside together, 3x plus 8x gives me 11x, and 8 times 1 is 8. So you can see that it works. So the factors are going to be the very first factor that I knew when I tested positive 1, the factor x minus 1 was in fact a factor. The next two factors came from the quadratic that was the end product of my synthetic division. That was 3x plus 8 and x plus 1. Remember that the order that you write these factors doesn't matter. As long as you have all three of them, you're fine. The order of the three parentheses does not matter. They could be in any order. All right, we're going to kind of crank up the difficulty just a little bit. Given that x minus 2 and x plus 3 are factors of this polynomial, I want to find the remaining factors. So here we know that x plus 2 is a factor. I'm sorry, I said that wrong. We know that x minus 2 is a factor, which means that we hopefully know that 2 is a solution or a root. We know that x plus 3 is a factor, which means that we know that one of the roots is also negative 3. We set that equal to 0. So we're going to have to divide by both of these roots synthetically. We'll start with positive 2. So I'm going to start with positive 2, and I'm going to divide into this guy. Do my countdown, 4, 3, 2, 1, 0. All of my exponents are there, so I can just copy down coefficients of 2, 7, negative 4, negative 27, negative 18. Now, if I know that 2 is a root, I should end up with a remainder of 0. I've done something wrong. So I'll synthetically divide, bring down the 2, multiply, add, multiply, add negative 4 plus 22 to get 18, multiply to get 36, add to get 9, and 2 times 9 is positive 18. When you add that down, you get 0. Now, please pay attention here, okay? This 0 here means that x minus 2 is a factor. All right, so we've got one of them down. Instead of starting over again, we are going to build our next synthetic division off of the results from this one. So I'm just going to come right here, pay attention, and divide by negative 3. I'm going to divide into the outcome, not including the remainder. I'm not including the remainder here, just the outcome of the first synthetic division. Negative 3 is going to multiply by 2. Then I'm going to add, then multiply, then add, then multiply. And remember, the last part is the remainder. The remainder is 0, so that means that x plus 3 is a factor. This is what we do when we have more than one factor or more than one root. We can synthetically divide several times until we get this down to a quadratic. It's a quadratic because we started with a 4th degree, we went to a 3rd degree, and now we're at a 2nd degree. So what's left behind is 2x squared plus 5x plus 3 equals 0. This is the quadratic that we have to solve to find the other two factors. So what multiplies to give us 2x is x and 2x. What multiplies to give us 3 is 3 and 1. Signs tell me that both of the insides are positive. And let's check and see if I got it right. 2x, 1 times 2x is 2x. 3 times x is 3x, and 2x plus 3x is 5x. So the inside and outside products add to give me 5x. I'm good. These are our other two factors, all right? So let's come over here and list out our factors. Our factors are, the first one, x minus 2, right? When we synthetically divided by 2 and it worked, that meant x minus 2 was a factor. When we synthetically divided by x plus 3 and it worked, that meant that x plus 3 is a factor. And then when we factored the resulting quadratic, that meant that the resulting factors were also factors. All 4 of them are factors. So we're going to list all 4 of them. X minus 2, x plus 3, x plus 1, and 2x plus 3. Does the order that you write all 4 of these parentheses matter? No, you just have to write all 4 of them. All right. Hopefully this is making sense. We divide synthetically by the roots, and we keep going until we get a quadratic. And once we get a quadratic, we factor it. If you'd like, try this one on your own. See if you can get it on your own without any help. And just pause the video, try it out, and then start the video up and see if you get it right. All right, let's see if you got this question right. In order to divide by x minus 10, we have to synthetically divide by positive 10. So we're going to divide positive 10 because x minus 10 equals 0. Solves to be positive 10. So we're going to divide by 10. Do my countdown, 3, 2, 1, 0. That's good. So I'm going to use just my coefficients, 1, negative 12, positive 12, and 80. Add, and I got a remainder of 0. Awesome. Now that I've got my remainder of 0, since this was an x to the third and I synthetically divided one time, I now have a quadratic of 1x squared minus 2x minus 8 equals 0. I'm going to factor this quadratic. I told you at the beginning of the year that you were going to be factoring a lot this year, didn't I? I hope that you believed me and practiced and got good at it. All right, so x times x is x squared. I need something that multiplies to give me negative 8, but adds to give me negative 2. And that would be negative 4 and positive 2. So negative 4 times positive 2 is negative 8. The inside and outside, negative 4x plus 2x is negative 2x. So that works. All right. So the first factor I got with synthetic division. When the synthetic division worked, that meant that x minus 10 was a factor. After working it down to a quadratic, I was able to find two more factors. So my factors are x minus 10, x minus 4, and x plus 2. Now I'm going to add a question here. Now that I know what the factors are, can you tell me what the roots would be? Or zeros, I could say zeros. Or solutions, I could say solutions. Well, if the factors are x minus 10, x minus 4, and x plus 2, that means that we could rewrite this thing as x minus 10 times x minus 4 times x plus 2 equals 0 to find the roots, which means that these three things are going to give us the roots. If we set all three of them equal to 0, we can find that the roots are positive 10, positive 4, and negative 2. You'll have to be careful as you're working through problem sets. Sometimes they ask for factors, and sometimes they ask for roots or zeros. And whatever the question asks for is what you need to give them as your final result, factors or roots. Well, I hope that you are feeling comfortable using synthetic division to find some factors or roots if you know a factor or root already. Remember, if you need help with this topic, you can always ask me about it in class, and I'll see you there.